This video will demonstrate how to create a constraint equation, also known as Nastran-MPC equation, in Femap. What is it? A user-defined equation relating nodal degrees of freedom. How is it implemented? Activated by case control command, which points to the actual equation defined in the bulk data. Rules. Equation must be in the form C1U1 plus C2U2 equals 0. First term in equation becomes a dependent degree of freedom. The degree of freedom is in the output coordinate system of each node. All nodes in equation should have the same output coordinate system. Connect only coincident nodes with user-written constraint equations. Use RBE-type rigid elements for non-coincident nodes. What can I do with it? Make rigid connections between nodes. Calculate some useful quantity that is a function of nodal displacements. In this example, we will connect two discrete beams by tying the x displacement of node 11 to the x displacement of node 22. This means the two nodes at the right end of the beams will have the same x displacement. For clarity, the beams are shown as non-coincident. To avoid modeling errors, only connect coincident nodes with user-written constraint equations. First, we write our equation in engineering form with ux of node 11 equal to ux of node 22. Next, we reform the equation with all terms on the left side of the equation equal to 0 on the right side. This form is required to meet the Nastran-MPC equation syntax. Now we will demonstrate the steps to create the constraint equation. Create a new constraint set for the equations. Now create the actual constraint equations. Now we enter the coefficient, select the node, and check the desired DOF direction at that node. Now repeat this process for each term in the equation. Now we need to modify the analysis to use the created constraint equation. Now create a new analysis or modify an existing analysis to use the constraint equations. Now let us look at the Nastran input file that is created by selecting the Preview Input button. Notice the case control section now has the constraint equation selected. Now if we scroll down into the bulk data, we see the actual constraint equation in the Nastran format. The results show that with the constraint equation off, the node 11x displacement is 0.0119 and the node 22x displacement is 0. The node 22 displacement is 0 because no loads are applied directly to the upper beam. With the constraint equation turned on, the x displacement of node 11 and 22 are identical at 0.00595. This occurs because we have tied the two nodes to move together, which means both beams are now resisting the applied force.